What is Math World? In this video we're going to talk about how to use the right triangle trigonometry, kind of abstractly here just with triangles, and then I will follow up with a third video kind of showing an application where I've used the right triangle and actually doing some construction. So let's look at this. Find the lengths of A and C. We want to find A and C given over here that we have this triangle with an angle of 28 degrees there, and the opposite side is 4, and we have a right triangle. So find the lengths of A and C. So let's go in this color. So the lengths of A and C. So let's focus on A first. So I'm going to say that the tangent of 28 degrees equals opposite over adjacent, or I really like to think of tangent as the slope, rise over run, so it's 4 over A. Okay, and now that I know that, I can multiply both sides by A, multiply by A, multiply by A. Here the A's cancel, and we get that A times the tangent of 28 degrees equals 4. Divide out by the tangent of 28 to get that A equals 4 over the tangent of 28 degrees. And now let's get out our calculator to get an approximation of this. So 4, first of all, let me go to mode to make sure that I'm in degree mode. So yes, we are in degree mode. So second quit. So 4 divided by the tangent of 28 degrees, and let's hit enter, and let's go with 7.523. 7.523. So this is going to be about 7.523. That should be good enough. 3 decimal places should be good enough for backyard carpentry. So we have that A equals, or is about equal to 7.523. Okay? So now I would find C. Let's switch to a color we haven't used here. Let's go with green. Okay, now we're going to find C. Well, how would I find C? I probably wouldn't use this 7.523 because I rounded that. I would simply use, let's say what's that going to be, the sine? The sine of 28 degrees equals, so the sine is going to be the opposite over the hypotenuse. So sine is going to be 4 over C. Now we can multiply both sides by C, get them to cancel there, to get C times the sine of 28 degrees. Make sure we put degrees in there when you're using degrees, because if you don't see anything, that means we're using radians. Equals 4. Now dividing out by the sine of 28 degrees, we want to get that C equals 4 divided by the sine of 28 degrees. Okay, now I'll go back to my calculator. Let's clear everything out and say 4 divided by the sine of 28. .520, so let's say 8.52, about 8.52. Okay, so that gives me that C. So I was asked to find the lengths of A and C. So we have here that A, so A was about 7.523, and C is about 8.52 using our trigonometric ratios. Okay, We're looking, doing good. We got 5 minutes left. Let's do another one here. Given this triangle, here we don't know what that angle theta is, but we just have theta there. We know the sides, the legs of the hypotenuse. It's a right triangle. We know the legs are lengths 2 and 3. So we want to find the length of the hypotenuse C and evaluate sine theta, cosine theta, and tangent theta. So how am I going to find C? So here we're just going to use our Pythagorean theorem. So we know that C squared equals 3 squared plus 2 squared. Again, Pythagorean theorem. So C squared equals what, 9, 3 squared plus 4. C squared equals 13. So C is going to be the square root of 13, and we're talking about a triangle here. So a triangle is always have it's not plus or minus, it's going to be the positive square root of 13. Okay, so this equals square root of 13. And let's leave it at that. That's nice. I mean, you could get a decimal approximation here, but if you're an engineer, you would. If you're math folks, you like to keep this nice, pretty square root of 13 there. Isn't that nice? So let's find let's use my colors here. Let's find sine theta. Let's do it over here. Sine theta. Okay. Sine theta is going to be what? Opposite over hypotenuse. Okay. So that is, now you got to be careful here. What is the opposite of this angle theta? Well, the opposite is the thing directly opposite of it. Okay. So that's going to be 3 over the hypotenuse, which is going to be over the square root of 13. Alright, and we should have rationalized enough denominators now that we know to multiply by root 13 over root 13 to get that sine theta is 3 root 13 over 13. That would be the mathematician's answer. So let's go to this color and let's get the, what's next, cosine theta? So cosine theta, so cosine is adjacent over hypotenuse. So if I'm right here at theta, adjacent is going to be there, and hypotenuse is there. So 2 over square root of 13. And so we get that cosine theta equals, again, multiplying by root 13 over root 13, which is the same as multiplying by 1. You haven't changed anything, but we've got the radical out of the denominator. 2 root 13 over 13. And let's go with tangent theta equals opposite over adjacent. Okay, and now here, if I'm right here at theta, the opposite again is the side 3, and the adjacent is the side 2. So it equals 3/2. Okay, I hope that helps you out solving for these right triangles. I'll tell you, this may seem kind of arbitrary here, but solving for right triangles and using the proportions of the sine, cosine, and tangent, I find to be one of the most powerful things that I've encountered in all of math. That is, it just occurs so often that it's something that you really need to know. In the next video, I'll build a treehouse, and I'll give you an example of where I used a few things where I used the right triangle trigonometry here. Okay, I'll see you in the next video, and you will find out what is O.